This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Hello and welcome to another live show here on SLU.com in the Clubhouse. My name's Will Gator and tonight we're once again celebrating Comet 67P Churyumov-Gerasimenko at perihelion. So of course the comet is reaching its closest point in its orbit to the Sun tomorrow, in fact. And tonight we're going to be talking a little bit about SLU and how it's been monitoring the comet over the past, well, many months really. On your screen at the moment you can see some of the pictures that SLU members have been taking. Fantastic pictures showing that beautiful fuzzy comet against the background star field. And so there's lots to talk about. I'm also going to be showing you some clips of the interview I did with Rosetta's project scientist, Dr. Matt Taylor, just a few days ago, of him talking about some of the science that his Rosetta mission has been doing. Because of course, in that coma, as he said so eloquently just a couple of days ago, in that coma, that fuzzy sort of region around the nucleus of the comet, that's where Rosetta is right now. And so SLU's telescopes are actually looking at the sort of big view. And to talk to me about, what we're seeing on screen and some of the things that SLU has been doing over the past few months, I'm really pleased to introduce now SLU's observatory engineer, Paul Cox. Hi, Paul. Great to have you on this morning.
Good evening, Will. Nice to be here as ever.
It's a beautiful comet, and we've been following it here on SLU for many months, haven't we?
Yeah, I think we picked it up very early from the Chile Observatory, SLU's Chile Observatory. It first appeared down there in the southern hemisphere, so that was pretty lucky for us. That's the image, one of the first images that we got. Of course, Comet was very low in the sky when it returned from being behind the Sun from Earth's perspective, and we've been following it ever since. Nightly, Will. So we've actually built up, SLU members have built up this fantastic collection of images every single night, which has been really, really valuable.
Yeah, I know we're going to talk later on in the show a little bit sort of about the science monitoring that SLU members are doing. But as you say, that night after night, month after month monitoring is quite crucial, isn't it? Tell me a little bit about the telescopes that have allowed us to do this.
Well, we've been using two key telescopes from the Canary Islands Observatory, and SLU's Canary Islands Observatory is a world-class observatory site. It's on top of a volcano. Most of the best telescopes in the world are on top of volcanoes in the Canary Islands, and you can see here the location and what makes it so special. And what makes this location special, a bit like Hawaii, is it's an island, a very tall island, 8,000 feet up, that's 2,000 meters. And it's got all of the prevailing weather, Will, comes in over the ocean. So the air mass comes in, is very, very smooth, and it rises up over the island, once again, very, very smoothly. And because we're at this high altitude, it means that we're usually above the clouds. I say usually, we'll come to that in a second. But The telescopes that we've been using are two of SLU's biggest. Our half-meter telescope, that's 20 inches, and our new 17-inch telescope. And they're really our workhorses on the top of Mount Tady in the Canary Islands. Now, these are huge telescopes for amateur astronomers and anybody else to use. They cost a fortune, but they're at this world-class observatory site with perfect seeing. So back to your question, it's really important that our image set was taken with the same telescopes, the same camera, the same filters, under roughly the same conditions every single night. So we have this fantastic continuity of our images, and I think we've got some of those images that we're going to share in the show tonight that SLU members have taken.
You alluded to it earlier. We actually were hoping to bring you some live pictures of the comet itself, because, of course, the reason we're doing the Clubhouse show at this particular time is because that's when it's visible from the Canary Islands and our scopes there. Unfortunately, as you can see, there's a bit of cloud over the observatory now. Paul, the Canary Islands is a world-class, as you said, a famous place for astronomy, but this is not particularly typical, is it, cloud up there on the observatory? Usually get quite a few clear nights a year.
This is incredibly unseasonal. For us to be clouded out in August is virtually unheard of. Our meteorologist, actually earlier on in the week, when this small weather pattern started a couple of days ago, was stunned. I've never kind of known him so shocked. He said, I don't know where this came from. We have a professional statistician, and we're the only people who have forecasts for this high altitude site, because it's like its own microclimate, Will. And he runs these fantastic statistical models, and this just came out of nowhere. You can see there's a slight yellow tinge, and that means that it's also got some Sahara dust in it as well. So in this image, this is a camera that literally looks at 180 degrees above the observatory. The two white things you can see on the left, those are the two domes, unfortunately closed up. We can normally see the half-meter and the 17-inch telescope kind of pointing out of the top. We can see a few stars there, can't we, pointing out through those clouds. But yeah, unfortunately, we got no live images tonight, which is incredibly rare, as I say, at this time of year. So disappointing, but we've still got lots of exciting images and those great interviews as well to look forward to.
Yeah, it's nice to actually see the telescopes all tucked up safely in their domes there, away from, if there's a lot of dust in the air, you don't want that getting on those lovely optics. And actually, some of the stars you can see, I can see right in that little gap at the top there. That's the constellation of Perseus. Next to it, the bright star Capella. And that reminds us, or at least sort of beautifully reminds us, what's going on at the moment in the night sky. The Perseid meteor shower, of course, is reaching its peak actually tonight and into the early hours of tomorrow morning. And of course, we have a live show about the Perseids coming up. In fact, you can tune into a live public show that we're doing. I know, Paul, we've got some fantastic stuff lined up for that particular show, haven't we?
We have, and we want everybody out there to join us. If they've got clear skies, we want them to take a laptop or their phone outside so that we can be the audio commentary for their Perseid meteor shower. But if not, we've got feeds from around the world. We've got feeds coming from the UK, from Canada, from SLU HQ here in Connecticut as well. And these are the things that we want you to bring along tomorrow night at 8 p.m. Eastern. So a lawn chair, picnic basket, hot drinks, warm clothes, as I say, your laptop and or cell phone, so you can listen to us or watch us, and also bug spray. We've also, Will, got that fascinating radio observation as well, which you're going to be telling us all about during the meteor shower. So this is spotting the meteors by radio, isn't it?
Yeah, we've got it all covered. We've got that fantastic system. So, even if you have cloudy skies wherever you are, tune in. Well, welcome back to our live show here in the Clubhouse on Slough. Sorry about our brief break. Our production studio, over in Connecticut, lost internet whilst we were broadcasting. But we're back now. Paul, just before we got cut off, we were looking at the live all-sky view of the cloudy skies. And we were about to go to the commercial break, but I just briefly wanted to talk about a little bit of some of the things that we've been looking at, these changes that we've been seeing on Rosetta's Comet 67P Churyumov-Gerasimenko.
Yes, I mean, it's been quite a difficult one, Will, to really spot large-scale changes because, it's not sporting a huge tail. Like some of the recent, I think, sighting spring was a great one that we saw recently. But here's a composite of some of the images taken just over a couple of months by Slough members. So this is all over the month of June, and we can see this gradual brightening of the comet, and the tail, I don't think really just came in with impact, as you can see in these images, and stayed. It's been kind of fluctuating up and down a little bit, and I believe that this kind of correlates with what the Rosetta mission have been seeing close up on the comet.
Yeah, there've been some amazing changes, and I think we'll talk about them a little bit later on. But perhaps rather than going to a commercial break, we could run the interviews that I did a couple of days ago with Rosetta's project scientist, Dr. Matt Taylor. And I don't know about you, Paul. I know you were listening in. Absolutely fascinating the things he was saying about how amateur images can link in and really help his team do their work.
Absolutely. I mean, we just love that to hear as Slough members, that amateur astronomers can contribute so much in the science of astronomy, and probably more so in astronomy than any other branch of science. And the other big message that comes out, and we'll hear him in a second, is with comets, expect the unexpected. And that's always a good place to start with comets. So fantastic interview. So let's look at those.
And I guess one of the things that for me, I think is so special is that your team and Rosetta has actually provided us an incredible close-up view, and so this dot really becomes almost a world in itself.
Yeah, I have to highlight, it's really important that we have these ground-based observations, both from the professional side and the amateur side, because that just gives us a fantastic context. If you consider, I think all the images that you can see, that we're in that dot, that nucleus is in 1 pixel with this spacecraft around it. So we haven't got that context when we're right up close. So it's highly important.
I think the last time I spoke to you, it was June of last year, and it was wonderful because when I was talking to you, you had so many questions, and I kind of feel over the last year, some of those questions we've started to know a lot more about. I mean, when I spoke to you last, we didn't even know what this comet looked like. It was just a dot as we were approaching it. How have things changed for you in terms of, you know, you and your colleagues' opinion of this comet? You know, what have you basically learned in the last year?
I think we knew this in the beginning, which was to expect the unexpected, and I think that's what we've learned, to even more expect the unexpected. I think, yeah, you highlight one of the most striking things that immediately came across from this comet was it changed from this grey potato, which I have a model of here. This is the, excuse me, sorry for running away. This is the old model that we had of the comet. Based on Hubble images, so it's this grey potato, and then it obviously changed into the duck-shaped like body that we know now. For me, that's one of the most striking things that happened to us here. But in terms of what we've learned, you know, I was asked this the other day, and I'm reticent to say we've learned this, that, and the other, because I look at Rosetta as up until the end of the mission. It's really, I wait for the end of the mission, and then we look back and look at the data as a whole, because the whole point, and I think you mentioned this earlier, is for us to understand how the comet works. So I think we'll really only get that once we've seen the full activity cycle, and that's the key thing here.
One of the things that you mentioned back when I last spoke to you is how difficult it is actually to fly around a comet. Has your experience over the last few months really sort of borne that out? Has it been a real challenge to sort of stay in orbit around the comet?
Yeah, even more so. Actually, we had concerns that we would not make enough dust measurements a couple of months ago, but late last year, and when we were planning for the observations we make now. And it is completely the opposite case. In particular, we need, through navigation, we need to be able to see the stars. We have these cameras, special cameras or detectors that are called star trackers, and they are getting very confused by that material that you see there flying out off the comet nucleus. So the dust in the coma confuses the spacecraft significantly, and we can't have that, because that jeopardizes the mission itself. If we lose the spacecraft, that's something we don't want to do. We basically need those star trackers to be locking onto stars so we have accurate pointing information. If we lose accurate pointing information, even basically the steerable antenna will start drifting away from Earth. We're pointing to Earth so we know where we are, and we'll lose the spacecraft. So that's been one of the major challenges that we've had to face, is the fact that the star trackers are seeing, or the dust environment is different to that we expected.
So I wanted to talk a little bit about why comets are interesting objects to study, Dr. Taylor. I mean, what can we learn from them?
Comets, along with other small bodies of the solar system, are considered to be like the leftovers, the debris that was deposited after the formation of the solar system. And comets, I have to say, are particularly interesting because they were slung out into the outskirts of the solar system. So the material that they contain within the comet, we find material that is very pristine. It's stuff that was there at the beginning. So by studying these bodies, by looking at comets, we get an idea of the material that was in existence in that state way back, 4.6 billion years ago. So I think that's the biggest hook you can have for comets, in particular from a human perspective, is where do we come from? They really are tapping into that specific question. How was the solar system formed? What was the material that made up the solar system? And in particular, connecting to us specifically on the Earth, why are we here? What makes us so special on the Earth? so far we haven't found other living organisms in the solar system apart from on this planet. So what makes us special? So it's that big picture story that we address by studying comets.
I think one of the most amazing things from this mission has been those early images that really sort of showed this incredible craggy sort of angular sort of shaped comet with these incredible lobes. I mean, I made a model just not long before Rosetta arrived at the comet to try and sort of put it together. I mean, can you? I just couldn't even sort of imagine that it would sort of look like this bizarre object. Is this the sort of thing we expect a comet to look like? I mean, how has Rosetta sort of changed our sort of view of comets, if it has? I mean,
well, if you look at other comets that we've visited, we have seen this bilobal-like structure. I mean, I think you might even be able to argue that Halley had a little bit of a bilobal structure, but it's not something as uncommon, as it were. But I think the thing that is very striking is how, as you say, craggy and angular and undulating the terrain is on the comet. When we first saw the comet, a lot of people were indicating various regions and comparing them to other comets that we've been to, Hartley and Bild. And it's apparent that, or at least for me, that it was a good, in hindsight, it was a good comet to go to because it displays features that all of the other comets that we've passed by have. So it kind of combines all of the features that we've seen before on comets, which I think is good. Again, going back to the ground-based observation. So if you consider this is a bit like a calibration. So if we have an in situ measurement with Rosetta, so Rosetta's there on this particular comet, and we have all of the scopes on the ground and also the near-Earth observatories looking at the comet at one time or another. They're not looking at it all the time. You can kind of calibrate those ground-based observations, and so what we learn from doing that matching, we can then apply to all the other comets. I think that's at a global level a really important thing to take on board, and that's why it's very important for the community on the ground, in particular the amateurs, because they're able to unleash their own wants. Yeah, they don't have to write proposals. Lucky them. And so we get much longer baseline observations from the ground-based amateur community, and it's fantastic. It's actually been very useful because some of the larger professional telescopes we couldn't use to see the comet in recent months. It's only now it's starting to come into above the horizon, as it were, for some of the bigger scopes. So all of this is very important in the global sense for scientific endeavour, to get an idea of how this comet evolves, and then also to apply that to all the other cometary observations we have. I mean, I've spoken to a couple of people, and maybe some people have got the New Horizons picture in their head that, it's like bang, and then that's, like perihelion's going to be this massive increase. It is the period now. So the beautiful images you were showing before from both the ground and at Rosetta, it's getting active now. It's been active for since last year, actually. It depends on what your level of activity interest is. But that occurs around the period of perihelion, and within the month afterwards, so into September, that's where we see the peak. One thing that's really important to highlight here, and I'm probably better to show from your big comet model, is that last year when we first started making this comet, this comet 3D structure and getting a feel for it, there was a large part of the comet we couldn't see that was not in sunlight. And you see that from your model. There's a bit that doesn't look really well resolved. There's about 30% of it at the beginning because it was not sunlit. It was the southern hemisphere of the comet. If you consider the comet to be a duck, if you think a duck has fallen over on its right wing and then is rotating beak first, that's how the comet rotates. Now, that right wing was not illuminated by the sun up until around May this year. Now, there you go. There's the duck rotating on its right wing. We are now moving. We've gone through equinox, so we're in the southern hemisphere summer now, from May this year through to March next year. It's a very short-lived period of time that the southern hemisphere gets illuminated. So that's an important thing to consider. The comet's orbit around the sun takes about 6.5 years, but only over that short time period of less than a year, about 11 months, that part of the comet actually gets illuminated. So that's even more pristine. There's even more material. Likely, if we just consider the whole solar energy into the comet, this input to drive sublimation, that's very short-lived for that region. So we should see, and we're beginning to get inferences, and hopefully we'll start to get a little bit more of that information, and maybe maybe as a little teaser, you might get a little bit of a show of that during the perihelion show that we have to see what that region looks like. And that's the thing that excites me. And we, as I say, we're starting to see more activity. Is it being driven from that region alone?
Well, that was Dr. Matt Taylor there talking about the Rosetta mission just a few days ago, in fact, as we were approaching perihelion, which of course is tomorrow. And really fascinating to hear him talk about how amateurs and even SLU members can contribute to the science that he and his team are doing. We're going to be talking more about that very shortly, but we're going to go for a quick commercial break, and then I'll be back with Paul Cox talking about how you in the clubhouse can get involved with the pro-am collaboration to study comets like 67P. So see you in 30 seconds. Well, welcome back to our live coverage of Comet 67P's perihelion, imminently, just tomorrow, in fact, here in the clubhouse. We've been following the comet for many, many months, and I want to bring back into the show now SLU's observatory manager and observatory engineer, Paul Cox. Paul, really, in terms of what SLU's been doing, the pro-am collaboration, that all started with another comet, didn't it? Comet ISON.
That's right. A project was started, I believe it was by NASA actually. They started the Comet ISON observing campaign, and very quickly SLU members wanted to be part of that, and we were, and actually we did the same thing with Comet ISON as we've been doing with 67P, and we built up one of the largest collection of images of Comet ISON from any ground-based telescope. But that kind of morphed in to what's called the PACA campaign. And PACA stands for Pro-Am Collaborative Astronomy. And it was, it's kind of been managed superbly by Padma Yanamadra Fisher, who was also a huge player in organizing the Comet ISON campaign. And Padma is also a SLU member, and we've worked very closely with her, especially one of our members called Christina Feliciano has been working very closely with Padma to get the PACA campaign into SLU and into the clubhouse. And what that really means, Will, is anybody, any SLU members can get totally involved in this real science of watching 67P and being able to do exactly what Matt was talking about there, compare the ground observations to what they're actually witnessing close up with the Rosetta spacecraft.
So how would someone go about doing that in the clubhouse? What are the sort of things that they can actually do to help?
Well, the first thing to do is pop over to the PACA group. So all you've got to do is in the little search bar, just type in PACA, and you'll go to this group that's been set up for it. And there's a join here page. And all somebody has to do is just comment there saying, I want to join, and they're made a member of the group. And then after that, any SLU astronomer members can make a coordinate mission to image Comet 67P, and then they can post their data to the clubhouse, and members of the team submit that to the PACA campaign and also to the Minor Planet Center as well. Now, if you don't know how to set up a coordinate mission, as we know, there are a few ways, aren't there, of setting up a mission to use the telescopes in SLU. One of the easiest ways is just choose from list, and it gives you a box with just the visible objects at the time that you've chosen. But there's also an advanced option in there that says, you know, put some coordinates in. Well, how do you know the coordinates of a comet? Well, in the clubhouse, there are plenty of links to an activity that we've done. It's a tutorial, a video tutorial that's really easy to follow, and it helps you set up your first Comet coordinate mission. And what I always say to people, Will, is it's far easier than you think. And that's where these wonderful images come from. So here's another member's image. This one is where are we from? May, end of May there, and we can just see how faint Comet 67P has been since we've been watching it. Not a spectacular comet, but this is something every time I see these images, well, to look at that little smudge and its little tail, and I know that the Philae Lander is on that little speck, and the Rosetta spacecraft and all of its fantastic instruments are orbiting it. I mean, it's just mind-boggling, the science that these guys are doing. You know,
It really,
yeah.
It really is. And what sort of things can we contribute in terms of the data? What can we learn from our SLU images, or what can we send to the scientists? What sort of data can they sort of reveal, as it were?
Well, a lot of it is with a comet. It's about the morphology of a comet. In other words, what's its coma doing? So maybe you can explain, Will, actually, to viewers now that the different components of a comet, and that's really what the professionals are after, as well as we can take what are called photometric measurements as well, which are measurements of its brightness. But just let's go back and maybe explain to viewers the basics of what makes up a comet.
Yeah, so at the heart of, we can see the comet at the center of that picture. At the heart of that, of course, is the few kilometer wide nucleus of the comet, which is this sort of, well, it's a bit of an icy dirt ball or a dirty snowball, depending on which particular scientist you talk to. But at the heart of it, that is that nucleus. And that's the thing that, as you said earlier, Philae has landed on. And we've got these amazing pictures from the surface showing those craggy cliffs, amazing pictures coming through. And then around it is really kind of what we see in our SLU pictures. It's something called the coma. So as this comet, this icy body, has come into the inner solar system, the heat of the sun has basically sublimated some of the ices from the surface. And what that means is basically they just go from a solid state straight into the gaseous state. And as they do this, they sort of shoot out from the comet and create this diffuse region around the comet that's mostly, all this material that's been thrown out. And as those gases erupt from the surface and push out, they also take with it a lot of dust as well. So you often see these dust tails sweeping out from comets as well as the gas tails. And so that's what we see in our image that's forming there. But you talking about the morphology and the changes. I wonder if our producer could bring in a picture from Rosetta from literally just a few days ago. This is the latest picture from Rosetta, and it shows one of the cool things that Rosetta is doing, and kind of, how it all links into what amateurs are doing in terms of the changing activity of the comet. Look at these pictures. They were taken 18 minutes apart. So you got on the far left, that was the first picture. Then 18 minutes later, there's this extraordinary bright long feature. And then 18 minutes after that, it doesn't seem to be there. And this is what's happening as we approach perihelion with this comet. And this is what I think is so exciting. We have never, ever flown with a comet as it takes this incredible journey into the inner solar system and seen these changes, seen these evolution. And so going back to what Matt was saying earlier in our edited highlight clips of the interviews with him, is the fact that they're seeing this changing activity. And this sort of activity can contribute, and we think probably goes into sort of changes in the coma too. So this is why it's important for ground-based studies and amateurs and of course us using SLU to monitor that comet, isn't it, Paul?
It is. And in fact, the Packer campaign have been stressing over the last few days and over this last week in the run up to perihelion. Just to remind viewers, perihelion is when the comet's making its closest approach to the sun. So in theory, it's when the comet's going to be most active. What they've been trying to stress is don't stop your observations now. This is actually entering one of the most critical and most interesting phases now, Will, because there can be a little bit of delay. We've seen this in other comets, that it's not necessarily the run up to perihelion, but it's a comet kind of gets this smack of gravity, doesn't it, as it kind of slingshots around in its elliptical or parabolic orbit around the sun. So that can stir up a lot of activity. And I don't know if you know, but just a few hours before the show, there have been some unconfirmed as yet, but some reports coming from one meeting of astronomers that some fairly large chunks have been seen image by Rosetta. I don't know if you've seen any of those reports at all.
Yeah, I saw it. I saw a couple of tweets from people. At the moment, the International Astronomical Union is holding its General Assembly in Hawaii, and of course, there's a lot of science presentations and some Rosetta scientists there. And yeah, I saw the tweets that you were talking about 40-meter maybe wide chunks flying off the
Well,
comet,
they
which is quite
gave
exciting.
quite a large range, though, didn't they? I thought that was quite
Yes,
amusing.
it did.
Anything from 1 to 40-meter chunks, but
Yeah.
either way, that's going to be fascinating if it's happening. And let's just keep on this set of images at the moment. This is showing SLU images, members' images over the course of last month, and it's showing the way the comet and the tail has been fluctuating, going up and down. And that's exactly what the pro astronomers are really interested in doing in the Rosetta team. You showed that image a short while ago, Will, of the sudden jet that lasted a very short period of time, only 10, 20 minutes, something like that. Well, what they want to do is they want to then compare that to any images that were taken from ground telescopes like SLUs to see what it looks like, what that activity looks like in the images from a ground-based telescope. And that is going to calibrate this kind of image. So when we look at images like these in the future for future comets, we're going to be able to say, well, actually, when Comet 67P looked like this, we saw this kind of activity on the actual comet. And that's his calibration that we're talking about between Rosetta and the ground-based telescopes.
It's fascinating actually to compare. You look at the 9th of July image there in the top line and then compare it to the one on the 15th, the way that changes. I mean, I don't know if that's a real effect or it's just a change in conditions maybe, but fascinating to see,
we
isn't
need to
it?
be a little, sorry, we need to be a little bit careful of maybe comparing some of those, because you can see, just to explain these images and some of the others that we've seen kind of the comet there with its kind of fuzzy tail, but we've seen these kind of streaked lines, as we can see there on the 9th. Well, that's because these images are combined. So it's a whole bundle of images taken during a single member's mission, and they're combined, but they're combined to overlay the comet. But of course, the comet is moving against the background stars as those images are taken. So the lines are actually the streak of the stars behind. So that's just to explain to people why they're seeing those kind of streaked lines in the background of the comet.
But there certainly appears to be changes in the actual coma between those pictures. It would be really interesting to get a scientist view. Maybe we'll have to get Matt Taylor back on the show and get him
Well,
to
he did
have a look
say,
at these.
we contacted him after the show. In fact, you even asked him during the show, and he said he will come back and give us an update. And that's going to be absolutely fascinating. And we'll pull together more images. So please, I would stress to other SLU members out there, if you're not already part of the Pro-Am campaign in the clubhouse, please join up. The Packer campaign don't want amateurs to think, oh, well, you know, it's reached perihelion, so we've done our work, now we can leave. No, this is just entering actually one of the most critical and most fascinating periods of this whole, the Rosetta mission and our involvement in it.
It's a really exciting time to be working with these telescopes and really helping out the scientists, and it really makes you feel as if we can really contribute something serious here, which is great.
Yeah.
We've got
and
lots
our
coming
producer,
up.
sorry, Will, our producer's just showing there, that is the campaign HQ in the clubhouse. Just click that, join the campaign here, and you'll be signed up to the group, and then set your missions up using either the half-meter telescope or the T2 17-inch telescope. Both of them are showing 67p. Absolutely beautifully, and post your images or your data to the group, and they will automatically be submitted, and you'll actually get all contributors will from SLU and other amateur astronomers who contribute to the campaign will get a certificate to kind of recognize their work. And this is Christina's one, Christina Feliciano. She's a long-time SLU member, incredibly active, and she has been working miracles behind the scenes to keep this whole project running for us. So huge thanks to Christina out there as well.
That's fantastic. Well, we've got lots more coming up on SLU over the coming weeks. Of course, we'll be following the comet for a long time yet. But actually coming up tomorrow, we have a special live public show, don't we, Paul? Fantastic live show looking at, of course, the Perseid meteor shower. Lots going on in that show.
We do, and we are doing this one slightly differently. This is over a 4 or 5 hour period. I'm going to be reporting live from SLU HQ. We've got a great weather forecast there. The weather in the Canary Islands is also going to be good tomorrow night, so we're going to be getting some fantastic Perseids showing up in the all-sky camera. But we've got everything. If you're whatever you're interested in astronomy and meteor showers, we've got it. We've got the science. We've got you doing radio astronomy. We've got, if anybody wants to use their DSLR camera to actually photograph the meteor shower, then you're doing a segment on that. We've also got the mythology of Perseus and Andromeda and Cepheus and Cassiopeia. So whatever you're interested in, people have got to come along and join us. Now, if you've got clear weather where you are, go outside with all of these things that we're telling you to take outside and enjoy the spectacle for yourself, but take your laptop or cell phone with you so you can listen to our commentary. We've got some fantastic music in the little segments that we're just going to be watching all of our various feeds. We've got hundreds of feeds coming from a whole UK monitoring group. Over there, Will. That's going to be fantastic. We've got them for the first time partnering us. We've also got a live video feed coming in from Canada, our partners at Thunder Bay Observatory. We've got fantastic DSLR views from SLU HQ, and we've got, of course, the Canary Islands. Notice here, Will, what's missing off this list? Telescopes and binoculars. This is one thing, this is one astronomical event that you don't need a telescope for. Oh, exactly. Should we really be saying that? No, we should. But if anybody has a pair of binoculars or just the tiniest little telescope, even just a handheld thing, then bring it with you, because at the end of the night, we're going to be showing you how to look at the Andromeda galaxy, which is part of all the myth of the Perseids, caught up in all of that. So we're going to be showing people where to find the Andromeda galaxy. And we've also scheduled both of the Canary Islands telescopes to show the Andromeda galaxy in its full glory. So you can tell, Will, I'm quite excited about tomorrow night.
I can. It's going to be a fantastic show. I'm really looking forward to it. And of course, keep in touch here on SLU. You can join us in the clubhouse. Keep talking and talking to us about the program collaboration. Of course, if you've got questions, I know that there's loads of people as well as Paul in the clubhouse that will answer your questions and help you get started in this fantastic world of sort of contributing to real science. But from here in the clubhouse, from Paul and I, thanks for tuning in, and we'll see you again next time. Good night. Hello and welcome to another live show here on SLU.com in the clubhouse. My name's Will Gator, and tonight we're once again celebrating Comet 67P Churyumov-Gerasimenko at perihelion. So of course the comet is reaching its closest point in its orbit to the sun tomorrow, in fact. And tonight we're going to be talking a little bit about SLU and how it's been monitoring the comet over the past, well, many months really. On your screen at the moment, you can see some of the pictures that SLU members have been taking. Fantastic pictures showing that beautiful fuzzy comet against the background star field. And so there's lots to talk about. I'm also going to be showing you some clips of the interview I did with Rosetta's project scientist, Dr. Matt Taylor, just a few days ago, of him talking about some of the science that his Rosetta mission has been doing. Because, of course, in that coma, as he said so eloquently just a couple of days ago, in that coma, that fuzzy sort of region around the nucleus of the comet, that's where Rosetta is right now. And so SLU's telescopes are actually looking at the sort of big view. And to talk to me about, what we're seeing on screen and some of the things that SLU has been doing over the past few months, I'm really pleased to introduce now SLU's observatory engineer, Paul Cox. Hi, Paul. Great to have you on this morning.
Good evening, Will. Nice to be here as ever.
It's a beautiful comet, and we've been following it here on SLU for many months, haven't we?
Yeah, I think we picked it up very early from the Chile Observatory, SLU's Chile Observatory. It first appeared down there in the southern hemisphere. So that was pretty lucky for us. That's the image, one of the first images that we got. Of course, Comet was very low in the sky when it returned from being behind the sun from Earth's perspective. And we've been following it ever since. Nightly, well, so we've actually built up, SLU members have built up this fantastic collection of images every single night, which has been really, really valuable.
Yeah, I know we're going to talk later on in the show a little bit sort of about the science monitoring that SLU members are doing. But as you say, that night after night, month after month monitoring is quite crucial, isn't it? Tell me a little bit about the telescopes that have allowed us to do this.
Well, we've been using two key telescopes from the Canary Islands Observatory. And SLU's Canary Islands Observatory is a world-class observatory site. It's on top of a volcano. Most of the best telescopes in the world are on top of volcanoes in the Canary Islands, and you can see here the location and what makes it so special. And what makes this location special, a bit like Hawaii, is it's an island, a very tall island, 8,000 feet up, that's 2,000 meters. And it's got all of the prevailing weather comes in over the ocean. So the air mass comes in, is very, very smooth, and it rises up over the island, once again, very, very smoothly. And because we're at this high altitude, it means that we're usually above the clouds. I say usually, we'll come to that in a second. But the telescopes that we've been using are two of SLU's biggest. Our half-meter telescope, that's 20 inches, and our new 17-inch telescope. And they're really our workhorses on the top of Mount Tady in the Canary Islands. Now, these are huge telescopes for amateur astronomers and anybody else to use. They cost a fortune, you know, but they're at this world-class observatory site with perfect sync. So back to your question, you know, it's really important that our image set was taken with the same telescopes, the same camera, the same filters, under roughly the same conditions every single night. So we have this fantastic continuity of our images, and I think we've got some of those images that we're going to share in the show tonight that SLU members have taken.
You alluded to it earlier. We actually were hoping to bring you some live pictures of the comet itself, because, of course, the reason we're doing the Clubhouse show at this particular time is because that's when it's visible from the Canary Islands and our scopes there. Unfortunately, as you can see, there's a bit of cloud over the observatory now. Paul, the Canary Islands is a world-class, as you said, a famous place for astronomy, but this is not particularly typical, is it, cloud up there on the observatory? Usually get quite a few clear nights a year.
This is incredibly unseasonal. For us to be clouded out in August is virtually unheard of. Our meteorologist, actually earlier on in the week, when this small weather pattern started a couple of days ago, was stunned. You know, I've never kind of known him so shocked. He said, I don't know where this came from. We have this, we have a professional statistician, and we're the only people who have forecasts for this high altitude site, because it's like its own microclimate, Will. And he runs these fantastic statistical models, and this just came out of nowhere. You can see there's a slight yellow tinge, and that means that it's also got some Sahara dust in it as well. So in this image, this is a camera that literally looks at 180 degrees above the observatory. The two white things you can see on the left, those are the two domes, unfortunately closed up. We can normally see the half-meter and the 17-inch telescope kind of pointing out of the top. We can see a few stars there, can't we, pointing out through those clouds. But yeah, unfortunately, we got no live images tonight, which is incredibly rare, as I say, at this time of year. So disappointing, but we've still got lots of exciting images and those great interviews as well to look forward to.
Yeah, it's nice to actually see the telescopes all tucked up safely in their domes there, away from, if there's a lot of dust in the air, you don't want that getting on those lovely optics. And actually, some of the stars you can see, I can see right in that little gap at the top there, that's the constellation of Perseus, next to it the bright star Capella. And that reminds us, or at least sort of beautifully reminds us what's going on at the moment in the night sky. The Perseid meteor shower, of course, is reaching its peak actually tonight and into the early hours of tomorrow.
This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Mm-hmm.